Hello, this is Mr. B. I want to go over prime factorization with you using the division by primes method, otherwise known as the ladder method, but what I like to refer to as the birthday cake, because who doesn't like birthday cake? Everybody. Okay, so we know that prime numbers have exactly two factors. So when we think about prime numbers, we're thinking about 2. That's the first prime, that's the lowest prime number. 1 is not prime, remember. 2 is prime, 3 is prime, 5, 7. These are prime numbers that we can use that will help us in finding the prime factorization. Using this method, division by primes, boring. Birthday cake, yes, everybody loves birthday cake, so let's use that. Let's find the prime factorization of 120. Big number right there. And so let's do that using this method. What we do is I start down low, and we're going to build our cake by starting low and building up. The ladder method is the exact same thing, but it starts high and then just kind of works its way backwards, kind of down in a downward direction. This is simply division. So we write a division, and we think a division symbol. We think about dividing by prime numbers. We want all of our factors along here where our divisors go. So 120 is even. We can divide by 2, and we simply follow a division process. 120 divided by 2 is 60, and let's divide again. Let's build our layers of cake. See, isn't that fun? That makes me hungry. Okay, 60. Can we divide 60 by 2? Yes. It's also an even number, so we can divide by 2, and we get 30. Once again, we can divide by 2 again. So we continue this division process. And in this case, now we have 15. That's not divisible by 2. It's divisible by 3, though. So we're going to go on to 3 and start saying I can divide that by 3. And top layer is 5. Well, we can still divide 5 by 5. That's a prime number. And look what we have on our top. It's our birthday candle. We can put a little flame on it, build your cake up here. A little creativity added into this. That's why I like this. A little creativity. I'm a creative. So our factors are located along the side. This is where our divisors are. These are the factors which we used to divide. So our list of factors is 2 times 2 times 2 times 3 times 5. If we multiplied all of those together, we would get 120. So this is finding all the prime factors using this method. It's called division by primes, or birthday cake. Now let's use this same method to find the greatest common factor of, let's say, 60 and 75. So what we can do is use that division method here, just one large division bar over both numbers, because our common factors are going to be those factors that we can divide by, the divisors that are common to 60 and 75. So in our minds, we're going to think about our prime factors. We're going to think about 2, we're going to think about 3, 5, 7, and rarely do we have to go past 7, but we might. 11, that would be next. So 60 and 75. Well, are they divisible by 2? Nope. 75 is not divisible by 2. It is not an even number. 60 is, that's great, but we have to find something that is divisible by both 60 and 75. So not 2, we're going to cross that off. Can we divide them both by 3? Well, I know 60 is divisible by 3, and 75, if we may have to do this, go off to the side, and see if 75 is divisible by 3, and we'll find out that it is. So we're going to put 3 as our first common factor, prime factor. So we would go through our division process here. 60 divided by 3, 75 divided by 3 is 25. And then we would build our next layer here. 20 and 25, I'm questioning, can they be divisible by 3? Well, no, 3 is not a factor of either one of those. So what about 5? Can they be divisible by 5? Well, definitely they can. So we're going to divide them by 5. And we end up with 4 and 5. Well, 4 and 5 don't have any common factors. 5 is prime, first of all, and 5 is not a factor of 4, so we end right there. Here's our common factors, right along this side. 3 is a common factor, 5 is a common factor, and any combination where we can multiply together is also a factor. So if we multiplied all of those, 3 times 5, 15 is also a factor of 60 and 75. So we would see 15 times 4 is 60, and 15 times 5 is 75. So let's just do one more example here. Let's just pick a couple of numbers out for the greatest common factor. How about 56 and 84? 56 and 84. So we're going to find the GCF. Okay, and you might be writing these down. We're going to start down near the bottom of our page. You can divide, and then remember we're going to start thinking of these numbers are in our head right here. Prime numbers. Not connecting very well. Here we go. So can they be divided by 2? Yes. And again, you may need to go off to the side and do division to find out what the answer is. It's okay. All right, next step. Let's take a look at 28 and 42. What can they be divided by? Can we divide by 2? Yeah, they're both even numbers, so let's divide by 2 here. All right, so now 14 and 21. Let's go through that same process. Can we divide both of them by 2? Well, 14, yes, but 21 is an odd number, so that cannot be divisible by 2. Can we divide it by 3? You might at this point think, well, 14 and 21, I know a prime number that we can divide both of those, and it's right here, right? We can divide them by 7, so let's go ahead and do that. Let's pull 7 out. And so 14 divided by 7 and 21 divided by 7. All right, here's where we can stop, because 2 and 3 have no more common factors. So where's our common factors? Right there. 2 times 2 times 7. We can list them out. And this, if we multiplied all of them together, we would get our greatest common factor. But other common factors are found in here. 4 is a common factor because 2 times 2. Here's 2 times 2. That's 4. 4 is a common factor of 56 and 84. Also, 14 is a common factor. 7 times 2 right here. You can multiply 7 times 2 to get 14. 14 is a common factor of 56 and 84. And then if we multiplied all 3 of them together, that would give us our greatest common factor. Okay, and that would be 28.